Mechanical properties of fluids. Exercise questions. Question 1. Explain why the blood pressure in humans is greater at the feet than at the brain. We know pressure P formally is HROG. So at the feet, there's a pressure of fluid column having height H equal to the height of the person. So as the height of the fluid column is more, pressure will be high. So it's an application of the formula P is equal to H rho G. While when you take the pressure at the brain, you can see it is only due to the pressure of the blood due to the action of heart. But at the feet, along with that pressure, there will be the pressure of the fluid column, which is equal to H rho G. Part B, atmospheric pressure at a height of 6 km decreases linearly half of its value at the sea level. So the height of the atmosphere is more than 100 km. Again, we have to use the formula P is equal to H rho G. P is equal to H rho G. Okay, so if you assume that atmosphere height of atmosphere is 100 km, then the pressure decreases to half at 50 km only, when H becomes H by 2. But here the question says that it is not at 50 km, at 6 km itself, the pressure is decreased by half. What is the reason? So here, when the height increases, the density rho also decreases. So the sudden decrease in pressure is due to the decrease in density of air on increasing the height. Then part C, hydrostatic pressure is a scalar quantity even though pressure is force divided by area. Okay, the answer we have discussed, because when we calculate the pressure, we take only the normal component of force acting on a particular area. So the directional aspect is not significant there as we consider thrust or the normal force acting on the area. Now, come to question 2. Explain why the angle of contact of mercury with the glass is obtuse, while that of water with the glass is acute. In simple terms, we can give the answer that in mercury, the cohesive force among the mercury molecules is greater than the adhesive force between mercury and the glass. While in water, the cohesive force among water molecules is less than the adhesive force between water molecules and glass. Okay, or another way we can say, in the case of water, when we take the case of water, we can see the angle theta is acute. Angle theta is acute when SSA, angle theta is acute when SSA is greater than SSA. Okay, in terms of surface tension, interfaces of surface tension also we can give the explanation. Okay, then next part B, water on a clean glass surface tends to spread out while the mercury on the same surface tends to form drops. Okay, again the answer will be of same reason. Okay, we can explain in terms of cohesive force or adhesive force, or we can in terms of interface of surface tension. Then next, part C, surface tension of liquid is independent of area of the surface. You know, Surface tension formula is S is equal to F divided by 2L. Surface tension is the force per unit length, not the force per unit area. That is the reason it is independent of area. Part D. Water with a detergent dissolved in it should have small angles of contact. Again, if the angle of contact is small, then water can wet the surface very efficiently, and that will improve the action of removal of dirt. So therefore, a good detergent should be able to reduce the angle of contact so that water can penetrate easily through the cloth. Okay. Then next, part E, a drop of liquid under no external forces is always spherical in shape. If there is no external force, then there is only one force acting there, that is the surface tension. And within a given volumes, sphere has the minimum surface area. And we know the surface tension always tries to reduce the surface area. A sphere or spherical shape has the minimum surface area. The drop acquires spherical shape because of surface tension. Then next, question 3, fill in the blanks. Surface tension of liquids generally decreases with the temperature. So why it decreases? Because when temperature increases, the molecular motion increases. It will reduce the cohesive force among water molecules. Therefore, we can say the surface tension decreases on increasing temperature. Then next, viscosity of gas. Okay, viscosity of gas increases. Viscosity of gas increases with the temperature, while it decreases in the case of liquids. Again, when the temperature increases, the molecular motion will increase. Already gas is at a very low densities. As the molecular motion increases, the possibility of gas molecules for coming close to each other is high at high temperature. While in the case of liquids, when the molecular motion increases, the liquid molecules have a tendency to move away from each other because of the increase in their speeds. So therefore, what happens? The viscosity of the liquids decreases on increasing temperature. But as the gas molecules are having more probability to come close to each other on increasing temperature, the viscosity of gas increases on increasing temperature. Then part C, for solids with the elastic modulus of rigidity, the shearing force is proportional to shearing stress is proportional to shear strain. Okay, shear strain, while for fluids is proportional to the rate of shear strain. This reason we have seen already that when the shape of the fluid changes, it does not remain the same, it will continue to change the shape. While in the case of solids, when the shape changes, okay, that new shape remains there. There is no further change there unless and until there is another force is applied. Okay, but in the case of fluid, that's not the case. Once you apply a force on a fluid column, the change in shape will continue. Okay, therefore, in the case of fluids, we have to take rate of shear strain. Then part D, for a fluid in a steady flow, the increase in flow speed at a constriction follows. So here two options are given, conservation of mass and Bernoulli principle, both are applicable. Then next, part E, for the model of a plane in a wind tunnel, turbulence occurs at turbulence occurs above critical speed. Therefore, when the speed increases, we can see naturally the turbulence increases. Therefore, we can say the turbulence occurs at a greater speed. Okay, that is the answer. Then next, question 4, explain why to keep a piece of paper horizontal, you should blow over, not under it. We have seen the situation. Okay, when you blow the air over the paper, the speed of air above the paper increases. When the speed increases, according to Bernoulli's principle, the pressure decreases. When the pressure decreases, you can have a comparison of pressure below the paper and above the paper. Above the paper, pressure decreases according to Bernoulli's principle, so that the paper has a tendency to move upward. Therefore, if you want to keep the paper horizontal, you have to blow the air above the paper. Then part B, when we try to close a water tap with our fingers, fast jets of water gush through the opening between our fingers. Okay, the reason we have equation of continuity, AV equal to constant. So when area of cross section A decreases, the speed V increases. Then part C, the size of the needle of a syringe controls flow rate better than the thumb pressure exerted by a doctor while administering an injection. So here again the equation of continuity, we have AV equal to constant. So AV, what is AV actually? Area into velocity will give rate of flow. So therefore, the area, the size of the needle indicates the area of cross section. That will control the flow speed. Okay, the rate of flow. Then part D, a fluid flowing out of a small hole in a vessel results in a backward thrust on the vessel. So the situation is just like this. If you have a hose in your hand and water is flowing out from the hose, then you have to hold it tightly. Otherwise, what will happen? You will have a you will get a push backward. So when water goes forward, the hose will have a force backward. We can say it is just due to conservation of momentum. Such many cases we have discussed in the chapter laws of motion. Okay, when the water acquires a momentum forward, the hose will get a momentum backwards. The same is the principle here also. It is due to the conservation of momentum. Then next, a spinning cricket ball in air does not follow parabolic trajectory. The spinning ball will have the Magnus effect. We have seen already. The spin will drag the streamlines in a particular direction. Depending on the direction of spin, where you get crowding of streamlines, area associated with the streamlines decreases, velocity of streamlines increases. According to Bernoulli's principle, you can see when velocity increases, pressure decreases, so that a spinning ball will deviate from its actual parabolic trajectory. Then, question 50. Data is given. Mass of the person is 50 kilogram. Diameter of the heel is 1 centimeter, and radius of the heel is also given. Now, you have to calculate the pressure. You can calculate pressure is equal to force by area. And area can have the radius, so F divided by pi r square, where F is equal to mg. M is given 50. So substitute the values and find the answer. Question 6. Torricelli's barometer used mercury. We have seen already. Then the mercury is replaced by French wine of density 984 kilogram per meter cube. Determine the height of the wine column for a normal atmospheric pressure. So here we can take atmospheric pressure, PA, is equal to H rho G. PA is equal to H rho G. PA is normal atmospheric pressure. Okay, the value we know 1.01 into 10 power 5 Pascal is equal to H rho G, where you have to H you have to find out. Then rho is given, that is 984, and G is 9.8. Cross multiply the equation and find the value of H, so that you will get what will be the height of the French wine remaining in the test tube due to atmospheric pressure. Then question 7. A vertical offshore structure is built to withstand a maximum stress of 10 power 9 Pascal. Maximum stress is 10 power 9 Pascal. Is the structure suitable for putting up on top of an oil well in the ocean? Okay, and depth is 3 kilometers. So you calculate the value pressure P is equal to F by A. P is equal to F by A. Now here H is given, rho is density of water, and all other factors. The depth is also given, and you just calculate the pressure. Okay, so here for calculating the pressure, you can use the formula P is equal to H rho G. Okay, P is equal to H rho G can be used, and find the value of pressure. If this pressure is greater than 10 power 9 Pascal, it's not suitable. If it is less than 10 power 9 Pascal, it can be used. So find the value of pressure using the formula H rho G. Then next, question 8. A hydraulic automobile lift is designed to lift cars with a maximum mass of 3000 kg. Mass is given. The area of cross section of the piston carrying the load is 425 centimeters square. Converted to SI unit. What maximum pressure would the smaller piston have to bear? This is question is from hydraulic lift. Okay, so calculate the pressure using the formula P is equal to F by A. Okay, so F is mg again, and find the value of pressure. Then next, question 9. A U tube contains water and methylated spirit separated by mercury. Okay, then the height of the mercury columns in two arms are in level. Mercury is in level there. So here the mercury level. Okay, at B and D, that is in the same level. Then next, 10 centimeter of water. So water height is 10 centimeter, while 12 centimeter spirit. 12 centimeter spirit. Okay, 12.5 centimeters spirit. What is the specific gravity of spirit? Specific gravity means relative density. Okay, so now we can see the mercury column is in the same level. So what does it mean? The pressure applied by the spirit here is equal to pressure applied by water. We can have this Hs rho s G is the pressure applied by the spirit is equal to Hw rho W G. Hw rho W G is cancelled. Then you are asked to calculate the value of rho s. and rho W, the specific gravity or relative density of water is 1. So because relative density is density of the substance divided by density of water. Here substance itself is water. So density of water divided by density of water, you will get relative density of water is 1. So that relative density of spirit you can calculate. Now question 10 is its continuation. In the previous problem, if 15 centimeter of water and spirit each are further poured into the respective arms of the tube, both arms an additional 15 centimeter of respective substances are poured. What is the difference in the levels of mercury in the two arms? Water is having more density. As water is having more density, when you add 15 centimeter of water in the water arm and 15 centimeter of spirit in the spirit arm, definitely water will give more pressure there. So naturally what happened in the water arm, we can see mercury goes down in the water arm. So when mercury goes down in the water arm, equal amount spirit mercury goes up in the spirit arm, equal amount. So now you can see this is the level of mercury. This is the condition of mercury there. And above this, you can see the spirit total 27.5 centimeter height. Spirit will be there. And water you have above this level, you will have 25 centimeter of water. 25 centimeter of water. Then the difference in height of mercury. Here you can see this will be the difference in height of mercury there. Now look at the condition. In the same horizontal level, we will have the same pressure. So here, take this horizontal level. In this same horizontal level, pressure will be same, which means pressure at this point is equal to pressure here. These 2 points pressure will be same. Now in the right arm you see it is the pressure applied by 25 centimeter of water. So I'm going to give the name, okay, point A and point B. At point A and B, equal pressures are there. At point A, the pressure is the pressure applied by water of height 25 centimeter. So we can have PW is equal to HW rho W G. And that is the pressure at A. Now come to pressure at B. Pressure at B means it is pressure applied by the mercury of height Hm. Mercury height we can take Hm plus pressure applied by 27.5 centimeter of spirit, which we can be written as we can have Hm rho mg plus pressure applied by spirit, that is 27.5 height centimeter height hs rho s g. So at B Pressure of spirit plus pressure of mercury. Now at A and B pressures are equal. So we can have PA is equal to PV. PA is equal to PV. Equate the quantities and find the value of HM, the height difference of mercury. Next, question 11. Can Bernoulli's equation be used to describe the flow of water through a rapid in a river? Explain. No, because Bernoulli's theorem is applicable only for streamline flow. A flow of river in a rapid is not streamline, therefore it is not applicable. Question 12. Does it matter if one uses gauge instead of absolute pressures in applying Bernoulli's equation? You know that when we consider gauge pressure, we will just neglect the atmospheric pressure. Okay. So here, suppose we apply Bernoulli's theorem for a pipe like this. Now you can see both these cross sections. Almost the vertical height is same. So pressure at this point means it is a pressure of liquid here plus atmospheric pressure. Here also pressure of liquid plus atmospheric pressure. But this is almost a horizontal pipe. So when you add atmospheric pressure here, P2 plus PA, and here P1 plus PA. Okay, so this PA will be cancelled. So only pressure difference P1 and P2 can be calculated. In such a situation, you need to take only gauge pressure. No need to consider atmospheric pressure. But if the height difference of the cross sections will be quite different like this, in such a way that atmospheric pressure at the first cross section and atmospheric pressure in the second cross section are quite different, a large height difference. In such a case, you cannot use gauge pressure. You need to consider atmospheric pressure also. But if the pipe is almost horizontal, okay, without any large difference of height between its cross sections, then you can use gauge pressure, otherwise no. Then next, glycerin flows steadily, okay, through a horizontal tube of length 1.5 meter, radius 1 centimeter. If the amount of glycerin collected per second at 1 inch is 4 into 10 power minus 3 kilogram per second, what is that quantity given? It is given mass per second. Then what is the pressure difference between two ends of the tube? Then remaining data are given. Here this problem can be solved using Bernoulli's theorem, but there is another easy way to solve this problem. We can use a formula. Just study this formula. Okay, V is equal to capital V. V is equal to pi P r raised to 4 divided by 8 eta L. V is equal to pi P r raised to 4 divided by 8 eta L. And the equation is known as Poiseuille's formula. This formula is known as Poiseuille's formula. And you should understand what are the various terms used in Poiseuille's formula. Okay, so in Poiseuille's formula, so remember this equation. Okay, it is Poiseuille's formula. Okay, now in this equation here in Poiseuille's formula, You have to see various terms. V is the rate of flow, volume per second. P is the pressure difference between two cross sections. Means this formula is used to explain the flow of liquid in a pipe. So if we have P1 and P2 are the pressures, then P1 minus P2 will be the pressure difference, which is represented by P. P is the pressure difference, R is the radius of the pipe, eta is the coefficient of viscosity, L is the length of the pipe. L is the length of the pipe, and fluid is flowing through the pipe. Okay. Then V is volume per second, which is not given in the question. Instead of that, you have been given the mass per second. So mass per second you can convert into volume per second. So volume per second V is equal to mass per second divided by rho, m by rho. So here instead of V you substitute m by rho. Remember, m is mass per second. Then substitute all the values. You are asked to calculate what is the pressure difference between the pipe. So P is the pressure difference between the cross sections of the pipe, which can be calculated. Now, question 14. In a test experiment on a model aeroplane in a wind tunnel, the flow speeds on the upper and lower surfaces of the wing are 70 meters per second and 63 meters per second. What is the lift on the wing if its area is 2.5 meters square? Density of air is given. Okay, so here you apply Bernoulli's theorem. You can take both the wings are in horizontal direction, horizontal way. So when you apply Bernoulli's theorem, you will get P1 plus rho V1 square by 2 is equal to P2 plus rho V2 square by 2. So V1 is 70 meter per second and V2 is 63 meter per second. So rearrange the equation and find the value of P2 minus P1. Find the value of P2 minus P1. And you are asked what is the lift on the wing. Lift on the wing means what force is obtained by the wing, okay, from the air. So how do you calculate that? Force is equal to pressure difference into area. P2 minus P1, which you have calculated in the first part, okay, into area. The total area is given is 2.5 meter per second square. 2.5 meter square. So into area, substitute the values and find the force there. Then question 15. Figure is given, and which of the two figures is incorrect? Okay, so here you can see it's a constriction. Constriction, we know, first we apply equation of continuity. AB equal to constant. AB constant means, you know, area cross section decreases, velocity increases. So at the constriction, speed is high. So we are discussing about constriction. So at the constriction, as area is small, then volume is, velocity is high. Then when velocity is high, pressure is low. Apply Bernoulli's theorem. So pressure is low at the constriction. Pressure low means, you can see this is like just like barometer. Pressure low means height of liquid should be low in the manometer. Okay, so this diagram is correct. Here it shows low pressure and here it shows high pressure. While in this diagram, we can see it is just opposite. So this diagram is wrong. Question 60. The cylindrical tube of a spray pump has a cross section 8 centimeter square, one end of which has 45 holes, each of diameter 1 millimeter. If the fluid flow inside the tube is 1.5 meter per minute, okay, is given meter per minute, then what is the speed of ejection of the liquid through the holes? Okay, so you have the pipe, the first cross section, the speed is given, okay, 1.5 meter per minute. So V1 is given, and V1 is equal to 1.5 divided by 60 meter per second, and its area is given 8 centimeter square, so 8 into 10 power 4 minus 4 meters square, that's value of A1. Then you have to find, here we have 45 holes are there through which the liquid is coming out, and V2 you need to find out. And how much is A2? A2 is equal to, there are 40 holes, each hole is having radius r, so 40 into pi r square is the total area at the other end. Now what you have to do, you have to apply equation of continuity. A1 V1 is equal to A2 V2. Substitute the values and find the value of V2. Next, question 70. Okay, a U-shaped wire dipped in soap solution and it is removed. And a thin soap film formed between the wires. And a light glider supports a weight of 1.5 into 10 power minus 2 Newton. The length of the slider is 30 centimeter, and what is the surface tension? Okay, the situation is like this. So we can have an arrangement of wires like this. Then the glider is in this way. So when you dip it in soap solution, a soap film is formed here. And here, this is the glider which can support a weight of 1.5 into 10 power minus 2 Newton. Okay, actually this weight is supported by surface tension, and you are asked to calculate what is the surface tension. Okay, you can use the formula surface tension is equal to F divided by 2L. F is given, L is given 30 centimeter, edge length 30 centimeters, so that you can find the value of surface tension. Next, question 18. Figures are given there. Okay, so figure shows thin liquid film, again the same situation. Okay, supporting a small weight 4.5 into 10 power minus 2 Newton. Okay, what is the weight supported by a film of the same liquid at the same temperature in figure B and C? In A, it can support 4.5 into 10 power minus 2 Newton. And here you have same liquid at same temperature. And you can see from the diagram, the edge length is same here in both the cases. That means value of L is also same. So 40 centimeter, here also 40 centimeter. So you can see the formula surface tension is equal to F divided by 2L. And in this equation, you can see here in both the cases, you have same liquid at same temperature, so surface tension is same, length is same, and the first one can support a weight 4.5 into 10 power minus 2 Newton. And definitely, this, in B and C also, okay, as S and L are same, the same force can be supported. That means in both B and C also, a maximum weight of 4.5 into 10 power minus 2 Newton will be supported. Okay.